Right, we are live. Just waiting a little bit before we get started. How's everybody doing? Do say hi in the chat and just let us know where you're from, where you're watching. So I'm obviously doing this from Bristol in the UK and very excited. It's already dark in here. So yeah, first live stream. It's gonna be fun. Okay. So today we are going to do the CSWA, but we're going to use FreeCAD. Now, Solidworks is a CAD program and it has a test that you can take, the CSWA, which stands for the Certified Solidworks Associate Exam. Now they make it available, a test exam, to just sort of give you an idea of what to expect and how the test will look like. So you then can go through this practice test, see the setup, see the exam sort of portal where you need to input your answers and how the sort of flow of the exam will be, just to sort of prepare you in a sense before you actually take the paid one. Now I've actually done this video, or I've actually done this exam almost a year ago, or more than a year ago actually, where I've gone through the practice exam. And if you're ever interested in taking the CSWA, do check that video out. But now we are not going to use SolidWorks. We are actually going to use FreeCAD. Now FreeCAD is a free software. It's also a CAD program. And we're going to have a look and see if we can replicate the practice test in FreeCAD, take the answers or the answers required by the practice test from FreeCAD, and we're going to compare it with the answers given by the practice test and see if FreeCAD actually can hold up in terms of accuracy and capability on if we can use it compared to using SolidWorks. So in front of you, you will see question number 1. So this is a PDF. This PDF is available online. I'm just going to go scroll a bit up. So this is part 2. I'm going to skip part 1. Part 1 is just sort of drafting questions, which was multiple choice, which is not dependent on a software using. That's just knowledge that you need to know. And so I'm skipping that. So we're going to move on to part 2, which is a part or a part that you need to create. And this, like I said, usually done in SolidWorks, but we're going to do it in FreeCAD. So this part 2 has got a few questions of them. So again, we see this is this nice little blue part. And here at the bottom, we have all the dimensions for the sketch. Now, the first thing I'm going to do is I am going to open up FreeCAD. So this is FreeCAD. I've closed down my start page. We can quickly go have a look. It's always good to go and have a look and see about FreeCAD, just to make sure that you are on the correct version. So I'm here on version 0.19, which is the most current version as of recording. So this should work, or everything that I'm doing here, you should be able to replicate if you've got version 0.19 or higher. So we're just clicking OK. Also, before we get started, there's just a few things that I've added to FreeCAD that will enable me to actually generate the answers. So when you go to Tools, there at the bottom there is an Add-on Manager, and it takes some time to load. And two in specifically I want to let you know about is the A2 Plus workbench, as well as the Assembly 4 one. So A2 Plus and Assembly 4 are workbenches that you need to create assemblies. Now, if you're familiar with the CSWA exam, you start off with a part design, and you need to weigh it, and then they check to see if the mass is correct, and that's how they grade you to make sure you've drawn or created the part correctly. And then the second part of the exam is then an assembly part, where you have a bunch of parts that you need to put together, and then you input the center of mass. And if you've inputted correctly and you've orientated all the parts correctly, then your center of mass will be correct and in the right position. So in order for us to do an assembly in FreeCAD, we need either one of these two workbenches. Now I started off with the A2 Plus workbench because when I had a look at what workbench I need, the A2 Plus one had all the mating sort of criteria that you're familiar with in SolidWorks. And for those that's familiar in SolidWorks, when you go and create an assembly, you've got this mate option where you then mate two faces together or two circles that's concentric. So I'm very much familiar with SolidWorks. My brain is literally wired to work in SolidWorks. I haven't worked in FreeCAD that much, so I'm constantly, it's like, I know how to do this in SolidWorks, but so how do I do it in FreeCAD? So the A2 Plus workbench sort of said, oh yes, it's got mates. I know how to use mates. I want to use the A2 Plus workbench. But then after I've gone and installed it, well, obviously being a beginner, I didn't really like using it. I struggled a bit, so I moved over to the Assembly 4 workbench, and much easier. It requires a little bit of forethought. You need to basically know, you need to prepare the parts before you use them in the assembly with localized coordinate systems, but that's fine. You can do that very quickly. So I stuck with the Assembly 4 workbench. Then in terms of part 2, for the parts where we need to weigh them, we're going to need a macro. So there's another tab, macros, there at the top, and then FreeCAD basically loads a list of macros from GitHub, and then you have a big list of all the macros that you can use. Now if you go type on Google how to weigh a part and how to get the center of mass of a part or an assembly on FreeCAD, they suggest the FC info macro, but it's not here. It's not on my list, and went onto the forums and they said, yeah, it might be a connection issue where it's not loading a list correctly, so try it again, and I've tried it a lot of times, and it doesn't show up. So I had to make a plan B, and it doesn't show. Oh, there we go. Center of mass is the macro that I'm going to use today. Now, obviously the name tells you what it is, center of mass. It gives you the center of mass of a part, but luckily, it also weighs it for you. So you just input the density of each individual part. If it's an assembly, or if it's just one part, just the density of the one part. And it gives you the weight as well as the center of mass. And today that's the only two things we need. So we need the mass, which we're going to use in part 2, and we need the center of mass, which you're going to use in assembly. So the center of mass macro does everything that I want. So I'm going to stick with the center of mass. I might, in a later stage, try and figure out why I couldn't get the FC info macro. It's because the FC macro info is almost like the similar one to mass properties in SolidWorks. So usually when you're in SolidWorks, there's a mass properties button that you click and it gives you a bunch of information. And the FC info macro is similar in look to that, and it gives you all that information as well. But center of mass, simplistic, does the job. We're going to use that. So those are the add-ons that you need to install beforehand before attempting this. Okay, all right, so let's get started. I'm going to create a new part, or a new file at least, and we're going to start off in the part design workbench. And it loads up all the little icons at the top, and you can see everything is needed there, and it's got a little task to create a body. So usually that's how FreeCAD works. It's got different workbenches, like I mentioned, the Assembly 4 workbench that we're going to use for the assemblies. Part design is for creating parts. So we selected the part design workbench, and we're going to create a body, and we're going to start off with a sketch, and immediately it shows you all the different planes. I'm just going to go XZ plane, and I'm going to press OK, and it orientates it for me. I'm just going to close this bit here. And there is our origin. So now we can get started in drawing our part. Now we can quickly go back to our sketch. So usually the idea, and this is universal if you're doing this in SolidWorks, if you're doing this in FreeCAD. In FreeCAD, I guess it's a bit easier, SolidWorks. But you sort of draw the rough outline of the part first. Don't put any dimensions in, don't put any relations in, just draw the rough outline. And then you start at a point and you start adding all the relations, all the dimensions, and you try and mimic this part or this sketch with all the dimensions, so that when you compare this PDF and your FreeCAD or your SolidWorks drawing, you can see where dimensions are missing because you've positioned them in similar positions. You can also see we've got our little B and our A, which is dimensions that's going to change, and we're going to have to input that in FreeCAD as well. So let's start off with drawing a rough sketch. Okay, so I'm going to drag this over to have all my sketching tools available, and we're going to use this polyline, because the polyline is when you click, drag, click. It's much easier than dragging using just a regular line. So we are going to, oh wait, let's rather let's start with the circle, because the circle we can put as the origin, so the middle of the circle will be on the origin. So that is the circle of the sketch, and then we're going to start off with the drawing. So that was a bit of a straight line, then a curve, and then another straight line, then another straight line, and now there was a little bit of a circle, and we're going to go 3-point circles. So midpoint, it's going to touch there, it's going to go somewhere like that, and then we're going to go and we're going to continue with, I never know why it's doing that, but anyway, we're going to continue with our straight lines, back to polyline, straight, it's going to come down, let's put it down there, going to go straight like that, a little small there, and then we have some circles again. I think this center line's, this circle's midpoint was about there, and then it's going to touch there, it's going to go like that, and then we have a, oh no, I need to reselect it, another circle whose midpoint was about here, select that, it's going to go something like that, and then I don't know why this is doing, but I need to do the line, so we do there, straight line, yeah, straight, and then we're going to connect the two. All right, so that is our rough outline. Let's just quickly go back. Yep, it looks like we did it correctly. So that's our rough outline, and now we're going to start adding dimensions. But before we do that, we need to also activate another workbench that we're going to use for our variables. Now, like I mentioned in this sketch, we have the B, or the A and the B, which is dimensions. And if you go down, there's the dimensions given, like A, B, and C, with C being the thickness when we extrude it. So these values are changing. So for the first question, it's given as 81 and 57. And then for the second question, when we go down, they're going to change it. And then sort of the idea in being efficient in time is, rather than going into the sketch and changing those dimensions manually, we're going to assign variables A, B, and C to those dimensions, and then we can just change the value of the dimension outside of the sketch, and then the sketch will just update, and it will be quick and easy, and we can just do it. So question 2 should take us a minute, versus if we had to go in, it'll take us longer, so we don't want that. So we're going to quickly create our two variables, and in FreeCAD, the workbench to use is the spreadsheet workbench. So we've changed over from the part design to the spreadsheet workbench, and then here we say create a new spreadsheet. And when we click that, need to wait a bit, it's creating the spreadsheet. Thinking, why isn't it popping up? I'm gonna try that again. Come on, spreadsheet, show yourself. Okay, let's maybe just go and save it while we're busy. Let's just go, let me quickly save it. And this was part 2, question 1. We're just going to save that. And then we're going to try again. Create a new spreadsheet. Save document under new format. Yeah, what? Create a spreadsheet. Why isn't it creating a spreadsheet? Please, sir. Please, can we create a spreadsheet? Okay, we will try that again in just a moment. Maybe if we close it, maybe it doesn't like it that I've got my sketch open. Let's try, there we go. There we go. So it doesn't like it when the sketch is open. All right, so it opens up a spreadsheet. This is essentially, you can see it almost looks like Excel spreadsheet with all the columns and rows. So we have 3 variables. So we're going to go A, B, and C. Oops. And C. So those were our variables. And now we're going to look at our question to see what the values were. Just going to scroll down. It was 81, 57, and 43. So that was 81, 57, and 43. All right. So there's our variables or values, and we're going to have aliases here at the top because we want to reference it in our sketch. We need to give it a name. So we're just going to say dimension A, dimension B, and dimension C. And you can see it turns yellow. The little cells turns yellow, saying that, oh, it's been aliased, and we can use it in our sketch. So we've got those. Those are the 3 values they've given us for question 1. So we can go back to our part. You can double click on our sketch, and we can start inputting it. So let's see where A was. So A was here, is the horizontal total length of the part. So we can add that. So we have our horizontal part over there and there. And you can see it is given us a little pop-out box, 109. And then we just click there at the side. And now we can put in spreadsheet and dimension A, and there it's listed. And we say okay. 81, you can see that is correct. Just input that in. Oh my, it was horribly gone and squished everything together. So we need to go and reorientate it. Oh, that's horrible. Okay, so we need to put it all back. Put it all back so that it makes sense. No, it's horrible. Oops. Bring that point a bit back. Nope. Okay, so I've gone and drawn the thing way too large to start off with. I'm trying to get everything back into something manageable. Let's bring those lines back in. Try and see if we can. Okay, I'm not gonna. Let's just. Okay. We're getting there. We're getting there. Let's do the circle first, just so we can get a representative circle dimension as well. That was 14 in diameter. So it gives us a radius here, so we can just say 14 divided by 2. And there we go. All right, so that was the actual size. So we can bring everything in and try and make it a bit more representative again. Because that is just ugly. That is just ugly. Bring everything in. I started way too large, way too large. Okay, it seems to be looking better. Okay, bring that one down, or something like that. Okay, all right, we're back to some normalcy. So let's continue adding dimensions. So we have dimension A, which is got dimension A. Now let's do dimension B. So, hey, Ratul, thanks for joining. So I've managed it because I've drawn this outline so many times, to be honest. It's this outline, I can do it in my sleep. I've done this way too much. That's why it's burned into my memory. So so I was saying 81, which was our dimension A. Let's just go have a look at what was dimension B. So that was the vertical total length. So now we can go and vertical total length, that was over there. Nope. Just that little vertices points. Okay, and again, we press that little FC and then we say spreadsheet to access our dimensions, and this one's dimension B. So there we go, and it gives us 57, which was correct. Oh, this time it didn't completely distort my whole drawing. All right, so we've got our 2 dimensions that is linked to our variables. Dimension A at the bottom, dimension B to the side. So those are linked to our spreadsheet, and you can see now, I'm just going to quickly show you. So 81, if we go back to our spreadsheet, you can see there was 81, and we just change that to 85. And we go back to our part, you will see, oh, it doesn't update because I think I'm in the, let's just close that out, go back in. Oh, it doesn't, 85, oh, that's so small. Okay, so that's changed to 85. So that's a nice thing. When we move back onto question 2, we just change the dimension and it updates without us needing to go into the spreadsheet. So we're just gonna change that back to 81, which it was originally. Yeah. Good idea, right tool. The constraints is, I must say, they are constraints. So these horizontal, there's little red lines. So they are constrained vertically and horizontally to an extent. So, but I just drew them way too large to start off with. I think that's a nice thing about SolidWorks. I don't know if you've noticed that when you use SolidWorks, you draw the rough outline, and when you change a value, it sort of dynamically changes, or what's the word? It, yeah, makes it bigger or smaller depending on that one variable that you put in, or dimension. And in this case, FreeCAD is like, nah, you draw it too large, I'm gonna have to distort everything. So do it right next time. Punishes you for your mistake. But yeah, SolidWorks is much more forgiving. FreeCAD's not. Anyway, let's continue. So I'm going to start off. Let's start off with 29, and we work our way clockwise. So 29 is our first dimension. So we're gonna do that. Boom, 29. Okay, and then this one was 45. So there's an angle dimension. All right, so that needs to be 45. So we're gonna say 180 minus 45. All right, now that's 45. And then the next one is 24. So that one over there is 24. And as I go, so the 29 is correctly orientated. As I go, I try and I position the dimensions so that they're similar to the sketch that SolidWorks given, or the exam is given, so that when I go back, if my sketch is not fully defined, I can go sort of compare them side by side and see, oh wait, there's a dimension missing. So if you try and keep the dimensions in the correct sort of layout as they were in the exam, that comparison will be much easier. Okay, so we've got the 24 over there, and then, oops, looking at there, so we've got the center point of that circle, which was 19, and that's 29, so let's do that. So we'll put a little circle, don't even know where this, oh, there's the center point. Come here, closer, no, don't do that. Okay, so that thing, I'm going to delete this because that thing is just gone way out of bounds. Let's bring that one back, and now we can reconnect it. Just bring that over there. Okay, so that's reconnected. So as I was saying, that point, this line needs to be on it. Okay, and there's the center point over there, and we also know the vertical distance from our little center point to that point over there needs to be 19. Okay, so that is correct. I'm just going to drag it out over there, and then there's a horizontal one between that point and that point was 29. All right, we're getting there, Let's just see, it was 29, 19. Oh, we can put in the radius as well. So the radius was 29 as well. 29. Oh, again, my little sketch is like, no, come on, there we go. All right. Okay, so we've got the 29. I'm just going to put that over there. Well, maybe let's leave it there. 29 was here at the bottom. Got our 19. We can move on. So we have our 29, 90, 29, and so we have here a little tangent relationship between these two lines with a radius of 5 for that small circle. So we're going to go and add those. So that is 5, yes, radius of 5, and then these two needs to be, where is it? This one over here, a tangent constraint. Okay, some error. Some other constraints conflicting, so I just removed it, did that one as well. All right, so we're getting there, Just gonna move that 5 over there. We're getting there. Next up is 19, so the distance there needs to be 19, and we've got our circle, and again 45 degree over there, 45 degree over there, it's 14, 14, the midpoint of the circle, so it was 19, which 19 was that? I was just, okay, so vertical distance, that one over there, that one over there needs to be 19 as well. And then the angle here was, let's just see. Okay, so that was again 180 minus 45. That's 45 over there. And then we also said this was 7, I think. I think it was 7. 7. Okay, and then our distance between, vertical distance for the center point and over there was 14. Similarly, the horizontal one between that one and that one was 14 as well. Okay, we're getting there, okay, so let's do that. Let's just take that one because that was at the top. This 14 was here to the side. Because that was 7. So we have our 7, we have our 14, 45 angle, 14, 14. And then here's a big 32 and a 7 there as well. So let's add that. Yeah, let's do that. 32, 32, 32. Okay, where's my 32? There's it. Let's just drag it again. So 32 is correct there, 14, 14. And also that point and that point needs to be 14 as well. 14. And we have our angle, our 45 angle over here, which is 118 minus 45. Okay, and what's going on here? Let's bring that one a bit up. Oh, these angles are so ugly. And it doesn't allow you. So in SolidWorks you get, again, I'm going to refer back to Solids every time because I mean I've been using SolidWorks so long. My brain thinks in SolidWorks. Like when I first used FreeCAD, I was like, oh, I want to use convert entities, and I'm like, where? There's no convert entities in FreeCAD. And I'm like, oh, googling convert entities, but in FreeCAD. And I'm like, oh no, you don't have that. I was like, oh, I need to make another. How do I get around this then? So it's quite funny. Like he's constantly like comparing it with SolidWorks, but the thing is, you need to remember that FreeCAD obviously is a software package on its own with its own little user interface, and you need to take it as is and how you get around certain issues. So yeah. Right, so moving on. Let's just see, I'm getting an error here now. Okay. Okay, there was an issue with my FreeCAD, with my streaming. It seems like it's okay again now. Okay, we're back, hopefully. Let me know if something happens in the stream. That'd be great. So let's continue. So that 7 thing I just need to put there. We got the 14, we got the 7. Need 10-degree angle there as well. So going there. That was 7. Great. Let's just maybe put, that was a line. There we go. Okay, so we're gonna bring this one back. Come on. Oh, it doesn't want to come back. What's going on? There we go, there we go. Let me know, it seems like I'm lagging. Let me know if I'm lagging. YouTube, I've got a second screen here and YouTube's like freaking out for some reason. So just let me know if something happens. Then I'll wait or repeat anything if I jump. So we got an angle there. So that was 180 minus 10. It'll give us our angle. And similarly, there was a constraint between these two lines. I had to make that tangent. And I think then as well, there was a requirement. Okay, so we have made that tangent, that 10-degree angle we've got. We need to put in the radius, and I think we already got the 29 there. So let's just put the radius in here. 29. Okay, so we got that, we got the 29. Oh, this thing is just looking horribly, isn't it? Let's just go there, let's move this a bit. There we go, Okay, so it seems like oh no, what's gone on here? Something's gone wrong here. Where's that other point? Where are you? Oh, there we are. So it seems like I've forgotten a dimension over here because it's gone and disappeared, that angle. Let's just have a look. That was 5. Okay, I forgot to put that in. So let's put that in quickly. 5. Go on. 5. 5. Oh, look, it's green. It's green. It means, so green means it's fully defined. It's fully defined. I don't think I've ever gotten a fully defined sketch this quickly for this part. It's like you mentioned, Ratul. I've done this so many times already, so I already know where the little errors is that I usually make, and it seems like that's paid off. So practice makes perfect. I've got a fully defined sketch, which is great. So that's done. I'm happy with that, so I don't need to worry about not missing a dimension. Everything seems to be okay. So now I can close my sketch. There it is, perfect green. Oh, that's wonderful. Does give you like a warm feeling, doesn't it, when you get a fully constrained sketch. Okay, right. So I was in the spreadsheet workbench, so I need to go back to part design so that I can extrude it. Now again, I'm using extrude because that is SolidWorks term. But in FreeCAD, it is called padding. So I'm gonna pad my part. And the length is 10. So again, I don't want 10. This is dimension number C. So I'm again going to use my little spreadsheet, and I'm just going to say dim C. And I think that was like 30 or something. 43. All right, and you can see there it's gone. Look, guys, it is finished. Let's just go and appreciate it. It's an ugly gray, so let's make that, see if we can change its color. Oh, we can. Nope, that one. Cancel. Let's make it a nice blue as the exam was. Yay! Oh, isn't that beautiful? Look at that. Nice. Yeah, so we managed that. So we can do question 1 in FreeCAD. So that's great. But now the test comes where we need to have a look and see if we can weigh it correctly. So if we, I think it was down here, if we scroll, it gives us the material. So here it is steel, 1020 steel, and the density is 0.079 grams per millimeter cubed. So we need to go and input that density into FreeCAD. Now you select the body and we go to macro. So like I mentioned at the start, I downloaded a macro, recent macros. I use it, I tested it out obviously, so it's recent. Center of mass, or maybe let's just go and do it the traditional way so that you can see where to go get it. So there's macros, list of macros, center of mass macro. We can say execute. We've selected the part, so it already kicks it in as a body. Default gives us 1,000 kilograms per cubic meter. Now the exam has given it to us in grams per millimeter cubed, so we can actually go and change it to grams millimeter cubed, and we can say 0.0079. So if you've got multiple parts, they'll list them here, and you can actually give different densities to different parts, which is something useful when you're actually creating an assembly. Or you can just give them all the same. So I'm just going to go here at the top. I'm just going to go 79, and here's a little checkbox just saying everything needs to be the same, and compute, and it gives me the total mass here at the bottom of 972.13. Now all the answers to these things are at the bottom, and there we go. Let's just put them side to side to give that sort of, oops, it's wrong. It's wrong. All right, it's wrong. It's not supposed to be wrong. I've checked this beforehand, so let's go and have a look why it is wrong. Let's just go, maybe these values are incorrect. Let's just go back up. I need to go back to my part. Where are you? There we go. Okay, so the three values were 81, 57, and 43. 81, 57, 43. So that is correct. So our A, B, and C are correct. So that means we did 943. That's interesting. Okay, so our ABC values are correct. It seems like we've made an issue in our sketch then. So let's go back to our sketch and let's just review everything. All right, so circle was radius given as 7. Oh, that's so small. Let's just go back. It's 7. So diameter is 14, radius 7. That's fine. 29, 45, 5, 24. So 29. This was 45. That was 5, 24. That's correct. And then we have 19, 29, 29. So let's just have a look at that. 19, 29, 29. That's correct. Our A and B's we know is correct, so that was the top, and this was the side. That's correct. That's radius 5 and 19. Let's just have a look at that. 5, and here's our 19, so that is fine as well. That was 7, 14, and 32. 7, 14, 32. That is correct as well. And then we have a 7, 14, and 45. Let's just go. That is a 7, 45, 14, 14. That was a 10 degree. That 29, was that supposed to be 20? 19, did I say 19 here? Oh, there's my error. There's my error. That needs to be 19. Whew, all right. Thought I'm gonna waste all your time giving you an incorrect model. So I got it, All right, we got it. So now it should be correct. So now we can redo the whole process, our beautiful blue part. Macro, recent macro, center of mass. Let's see, let's go. Oh, now I need to redo all this. So it was gram, millimeters squared, millimeter cubed, 79, and I'm gonna do that for everything. Calculate. Oh, that still doesn't look correct. Let's just go and have a look. 963. Let's just go over there. So now 9. Oh, it's still not correct. How is that possible? I've gotten the error and it's not correct. Do apologize. When I practiced it, it was working, and now it isn't, which is really frustrating. So let's just see. That was a radius of 19. So I did get that right. Radius of 19. That was 10. That was 29, 45. Everything seems to be okay. 29, 14 radius. And the fact that it's fully defined means there's nothing that I missed. So it means it's actually a dimension that I got incorrect. That was 5. Yeah, that's 5. Oh, that writing is so small. $135. That's 45. That's 45. 7. 7. Yeah, let's try that. So there it is. So that is the 170. If we delete that, we can redo it. And I just see. So between that straight edge and this single one over here. It was 10 degrees, so that's 180 minus 10. So it does give that. I wonder if I got my, let me just see here. Yeah, 0.0079. 7, 19, 29, 19, 29, 19. It's all correct. Everything is correct. 7, 45, 14, 10 degrees. Yeah, so that's 19, 29, 5, 24, 19, 29. I wonder if that, let's just have a look. 29, that's correct. 29, that distance. 19, I did put that up. 19, 19. 5, tangent. Yeah, everything's correct. I do apologize about that. It seems like I cannot find my error for some unknown reason. Let's just redo this again. And then we move on. But that's going to mean all my parts are going to be incorrect. So like I said, I've practiced it. So I'm going to reload that one, which I knew is correct. And then we can continue from there. So let's just redo it just for the sake of it. Oops, I forgot to select my part. So body, macros, grams per cubic millimeter. It was 0.0079, which was the given density. I mean, 0079, which is correct. 9.63, which is incorrect. So that's a shame. Do not know why it is wrong. I am going to load up the one that I actually did, which was correct. So if you bear with me, we can go and have a look and see where that was. Oh, it's not even here. Let's just see if it's here. Otherwise, Ratul, how are you doing? Seems like it's you and I at the moment. So let's just go. Oh, I don't know where I saved it. I saved it in downloads. That's really weird. Let's go. Test pod. Oh, here we are. Here we are. Here we are. Let's open that up. Oh, it's opening up. Oh, I don't want the second one. Okay, so there's the correct one. Well, I'm a bit disappointed that my part isn't working and I don't understand why, so I'll definitely go and have a look and see why it isn't working. I'm just going to close this again and open it up in the other one. So let's just open that up again. Really. Where is it now gone? So here's the one I tested on, and we can go have a look actually. And we can do that, and we can say macro, recent macros, center of mass, and we can do this whole thing. Hopefully this is the last time we're doing it. 7.9 and 9.39, which is also not the same. Oh, there we go. That's exactly the same. There we go. 939.54. So that is part question A. And it's exactly the correct answer, which makes sense because it's the initial parts, very straightforward. There's no really complex geometry, so you'd expect them to be correct. So FreeCAD can actually go and do the same thing as SolidWorks for this one. So let's just go and save this one as, and we continue with that. Yeah, so Ratul, I think relations has something to do with it. I have faced this issue several times. I have to find just like the question. When I check the answer, it deviates a lot. Yeah, so I think so. If you do come up in this situation in real life, in the CSWA sort of thing, then I think I've actually done this in my actual CSWA exam. I didn't get the answer and I just sort of deleted the whole part and I redid everything again. And then for some other reason, it actually worked. It was so weird. And I was like, why? Why is this working? Why is this working? And so yeah, so it just worked the second time around, and that's it. So we're just going to go and, yeah, so that was our spreadsheet. Where is it now? So, no man, what's going on now? Let's just close everything again and open it up. Save, yes. Save it again. Open. Oh no. Sorry, I am horrible in saving. Hey Kev. Oh, you're a Ricardo Wave fan, that's great. Yeah, Ricardo Waves has been, I'm really glad it helps out. I must say, when I started out with Ricardo Wave, there was absolutely no resources at all on the internet. I was just like, why isn't there anything? So glad you found it useful. All right, so we're gonna continue with this one. I'm gonna quickly change its color again because it just looks better in the nice blue that is given in the question. There we go. And let's continue to part B. So going down, and like I said, now this is the part where having having gone and defined variables, because here we can see that they've just gone and changed the variables. 84, 59, 45, that's the only thing that's changed. And all that I need to do now is I need to go back into my spreadsheet and I need to change these values. And it will update the part, and I can weigh it again and I can get the value, the answer, and that's done. So that's 84, 59, 45, 84, 59, and 45. And now if we go back, I actually had to tile this so you can see it changing. So now it's changed. Obviously you haven't seen it, but if you put them side to side and you change the values, let's just do that, because it looks really nice when you do that. So you can tile them. So now you've got a variables on the one side and the part. I'm just going to go out a bit. And now if I go and I put this back to 81, you can see it shortens a bit. So look out. Yeah, do you see that? It's shortened. So it's updated it, and that's really nice. And this is true for FreeCAD, and this is true for SolidWorks. It's a parametric design. So you can actually have all your variables in all your dimensions as variables, and then you can change it dynamically and the part will update, which is really great. So you can just see, so I've just changed it to 81 again. So I'm going to go back to 85. It was 85 or 84, I can't remember. Let's do 84. So if I enter, now you'll see it'll become longer. And it's longer. So that's nice. So that was done. That was 84. Okay, so that's correct. So now again, part 2 of question 2, the second part is done, because I've gone and I've updated it. I've used the spreadsheet workbench, which makes my life a lot easier. So I'm just going to quickly go. I'm going to save it as this thing before I check it. So we're going to do that. And we're just going to say that was question 2. Let's just go to, whoops, no. Question 2, and now again, we're going to select the whole thing. We're going to use our little macro center of mass, and every time I need to update this. So just going to say 79. I'm going to check it for everything, compute it, and now it's 1032. Now I think I can remember this is actually the correct answer. Let's just go and look at that right at the end. 1000. Let's put it together. There we go. So 1032.32 grams, and it's spot on the same. So I've just gone and I've changed the variables. It's updated, it's become a bit bigger. So now it is weighing more, and that's exactly the same. So that's great. So question 2 done. Yes, that was fun. And now let's go, and I'm just going to save it as again for my next question, because I like to keep it separately, especially if I want to go back. So now the interesting part starts, because now we're going to create some changes to the part, which becomes difficult, because obviously this exam has been created to test your skills in SolidWorks. So they want you to use features in SolidWorks to do this. And if I'm doing this in SolidWorks, I would have done this in a matter of minutes, because I know what tools to use to get this part modified to that sort of type. The problem is here, it takes a bit longer in FreeCAD, but we can still do it. So I'm just going to go down, I think. So again, they've given us A, B, and C, which is different. So I'm going to update that first so that the parts change before I start modifying it. So it was 86, 55, and 44. So again, we're going to tile it, because it's always fun to see. Where's my open up spreadsheet? Let's tile it again. It's always fun to see the part change as we go. So I'm just going to get 86, got a bit longer. Ooh, I can't remember the values. 58 and 44, 58 and 44. All right, so it's updated for our question 3. So that's done. And now we can go back and we can add the changes. So it's a bit of a cut. So we have one cut over there. We have a cut here at the bottom, and we've got some sort of cut here in the middle. So if we go back, and this already, if you are very much aligned with SolidWorks, you would say, oh, just click on the face, create new sketch, and draw it and cut it. Well, doesn't work in FreeCAD. So we're going to go into Part Design Workbench, which we're already at, and we're going to create a new plane. A new plane that is going to be parallel with this XZ plane, which you're going to sketch on. Yes. And then we're going to select Yeah, so it's that one, so it's parallel with that, and we're going to offset it with our C value because it's now been extruded, padded, padded a certain distance to the front, and we want the plane to be right at the front of the part. So if ever you go and change the C value again, our plane will move with it as well. And always make sure that that new plane that we want to sketch on is in fact at the front of the part. So we need to make sure that is done. So I'm just gonna have a look and see. I think it's the, so we're going to do in Z direction. I'm just gonna change it. Yeah, so that's correct. So we're gonna again do the spreadsheet. And we're gonna go get our dimension C. See, when I press OK, the plane is at the front. So that's where we want it. So we're gonna go and we're gonna sketch on that plane. So let's just hide all these things again. So datum plane, we're going to create a sketch. So we click sketch and it nicely orientates it for you. Yes, so Ratul, like you said, I tried selecting the front face of the part and then nothing happens because obviously in SolidWorks it pops up, say, oh, new sketch, and you say, yes, please, and you just get going. Versus here, it's a bit more involved. And I know there's issues, they call it the FreeCAD topology issue, where if you update it, it's got some naming issues where it renames certain features of your part. And then if you make changes, the names or the references are broken. So it's just absolutely chaos. So if you want to go have a look at that, there's a few things how to get around with it. There's another FreeCAD program that's parallel with the official one, which sort of addresses it in a sense. And I'm fairly certain in the future FreeCAD will implement that into the official documents or the official release. But for now, we have to create a plane to sketch on. So I've done that. Hey, I thought, oh yeah, there's my sketch. Let's just go back into that. Okay, so I'm gonna hide the plane because it just looks weird. Okay. Now again, I'm gonna, like I said, I'm gonna refer to this the whole time. Is that in SolidWorks you can just say convert entities and click on the edges of the side of the part, and it will convert it to a sketch, and you can just use it as is. There's no feature like that in FreeCAD, so you need to get around with it, so around that issue. And how I do it, and obviously there might be a better way of doing it. Everybody has their own method of doing it. So I'm going to create everything as construction line, and I'm going to click here. So here's a feature here called create an edge linked to an external geometry. So I'm going to click that. Obviously I want to just, come on, there we go, that one over there. So I'm just clicking the edges and it's creating those lines. Yeah, I have never used FreeCAD. I've not used AutoCAD before, so but yeah, it sounds like everybody has this issue. All right, so it's gone and added these lines, which is the edges from my part, and you can see we need to cut it. So let's just go there. So we have that line which is 52 from the side. So in order for me to reference the side, I also need to duplicate some line over there, which I can go and then reference it. And then obviously we've got a line. Okay, I'm just going to go back to a normal line. And I'm just going to go there. There's a line that we're going to go cut it with. Okay, so there's the line. And it said it needed to be 52. So we're going to say that point, and that point needs to be 52. That was almost correct. All right, so there's that line is now there, and we're going to go and cut into that side. The problem is, as I understand it, I cannot use these purple lines. So I need to go now and draw over them with the normal line tool and just sort of go to the points. And you will see it is green, which means that there's a relation between that point and whatever I am drawing. So there you can see that part there is green, which we're going to use to cut into the part, and that's what we're going to use. So that is perfectly fine. I don't know if it's the cleanest way to do it, if it's the correct way to do it. Like, I'm still very much new to FreeCAD, but I'm learning as I go. So if you've got any better suggestions for those of you that are FreeCAD veterans and you're looking at this and saying that's absolutely the wrong way to go about it, do let me know, and I'll mend my ways and go about doing it that way. So here is our cut. So we're going to create a pocket. So it's called a pocket. We're going to pocket it. And let's see. So there it's going into that. It's 5 millimeters by default. And we want it to be 19. So we're just going to update that. Update it to 19. 19. There we go. So that's done. Fairly straightforward. And now the next part is here at the bottom. So again, the nice thing is I'm going to still use it on my plane, which I've created. Going to create another sketch. It's going to normal it. So now we're going to use this part over here. So again, what I'm going to do, I'm just going to create edges. If we go and look at the spot here, again, the height is 19. That's the only thing that really give me, apart from having to sort of follow this profile. I was looking at it, I was like saying, oh, why don't you just create a little like rectangle that's got 19 vertical height, and you just put it like that and it just cuts in. That can work as well. That can work. That's one way of doing it. Yeah. I'm not gonna do it like that, but that's definitely a way we can do it. I'm just gonna go and try and do it as I would have done it in SolidWorks again, which is not really the best approach because this isn't SolidWorks. But anyway, so let's do that over there. So those lines are there, and then we just have a horizontal line that goes from that point straight onto there. So there you can see again, being green, meaning it's fully defined. You can see there's a horizontal constraint. It is horizontal, but then I need to trace this purple line, because actually if you go and if you close it and you just use that sketch and you want to pad it, it just disappears. It just doesn't do anything, so it's not working at all. So we need to go and close this sketch. Even though those purple lines are there, we need to go and trace over them with actual lines. So we're going to go over there, over there, over there. Oh, I've gone, and this one is not fully defined. Let's just do that. So those two lines need to be the same. I've done that error there. Oh, there we go. That's just those two needs to be there. No, man. Let's just redo this whole thing. Go away, go away. Let's just delete that. Okay, so line again from that line to that line. Oh, missed it again. I need to zoom in, but it doesn't really get bigger, does it? Let's just do that. Oh, there we go. There we go. Oh, now it's green. Great stuff. And there we go. Okay, and now we need to do the quarter circles. So center line over there. Over there, so that's fine. And then I think actually that would be the center line of that one. Yeah. There we go. All right, so we've gone and traced everything. So now that fully defined, it's green, we can now use it to cut into the part. So we close that and we say cut. And I think this one is also 19. Let's just go, yeah, it's also 19. So we just update that to 19. And there we go. That is done. So that is done. All right, so we got our two cuts. And then there's a circle here, which you can do, which is again, fairly straightforward. Again, just use the plane that we've created. And we just have our little circle here. But now in order to add dimensions on the sides, which was 14 and 14, I think, I'm going to again create these little reference purple lines from the edges. So I just need those two over there. I think you can actually, so I'm doing the lines, but I'm actually just using the points. So you can actually, I think you can just click on the points and it will recreate the points. But yeah, I'm just doing the lines, which is fine. So there's our circle. Let's just have a look. So it's got a diameter of 11 and it's 14 and 14. So that was correct. So we go over there. See, there's the point. Let's just say 14. And then the same for the other one. Over there, 14. And then just the radius, they said the diameter was 11 divided by 2. And it's green. So that is done. Great. We close that. And we cut through it. And now we can just say, rather than dimension, we say through all, because the whole goes through the whole part. Okay, so I'm just going to save that quickly. All right, now the last thing we need to do is this middle cut part. And we need to do that. And this, if you've ever watched my video where I do this exam, but I do it actually in SolidWorks, this really stumped me on how to get this done. Since then, I have figured it out. Like I said, Ratul, practice makes perfect. So we are going to do this. Now, the thing is, we're going to create another another plane on way to, let me just see that. Okay, so here, so what we're going to do is we're going to maybe create a plane that's 12 millimeters offset from the back. And then we're going to draw our part and we're going to cut to the front. So that's how we're going to do it in FreeCAD. Is that the best way? That's working for me, so I'm going to do that. If it's not the best way, then do let me know. So we're going to create a plane and we're going to select, oh no, I don't have that. Let's just do that, change it. I'm going to select that plane. Oh no, what's happened? Okay, maybe let's just redo that. Tasks, don't want the origin. I want that plane. All right, there we go. And I think it was the Z. So here we're just going to say 12. Let's just have a look. Yeah, it's gone to the front, which is what we want. So that's okay. So now we've got a new plane. That is where it's supposed to be. By the way, for me to make things appear and disappear, I just select it and press the space bar. That sort of makes it appear and disappear. So that's how I make the planes appear and stuff. And this one over here, selected, press space bar, it disappears. So I'm just going to select that and I'm going to say create sketch. And now we are at that plane, even though you can't see it. Now before, so what again, if we look at this part here, and I'm just going to go to the bottom. So we're going to essentially have a little piece of circle that we're going to have there, and it's going to trace the other parts and we're going to cut it. Now, in order to do that, essentially we need to go and again recreate these edges, and we're going to trace over them. And so in order to get all these dimensions as well. So going back to that, we're going to select our little trusted tool that we've been using so much. So there, and that one. So those are all of them that we want. And now because I've done it, those are the edges I want. I'm just going to, for ease of use, I am going to hide this whole thing. So again, using spacebar. And now you can see that's just a sketch, and that was on the plane that we created. So the only thing left is our partial circle. So the center point was somewhere here at the top, and it's going to intersect that part. It's going to intersect that part. So there is the one part that we actually want. So there was some relation. So this midpoint was vertical with that line. So we're going to create that vertical condition. Did it do it? It didn't look like it did it. We'll go back to that now. Radius of 41 and 36, that part there. So we're going to go radius of 41 and vertical distance of that point, and that point was 36. There we go. Okay, and it seems like these 2 points are not vertically aligned. Okay, so there's a fixed point somewhere that is causing this issue. Let's just look, if I move it, yeah, I can move it. Why is that an issue? Let's try that one and that one. Doesn't, okay, let's just first retrace the whole thing and then we can try it again. So I'm gonna go and retrace all over this thing. The dots are so small. Okay, there we go. And polyline over So those are my lines, and now just that little piece of circle over there. So center line up to there and up to there. Okay, so that one isn't green. Why isn't it green? It is connected there. Let's just see those two are connected. Yeah. See at the top. Yeah, that's fine. All right. Let's try and align these 2 points. Still not want to align that. And let's try it again. Still doesn't want to align. Okay, so there is something issue now. So don't know why it's doing that. Let's maybe try a different point. Those two. Oh, there we go. Yeah. Don't know why that worked and the other one didn't, but it worked. I got a green sketch. You want it to be green. Green is go. Let's go. We have finished our sketch. We can exit that. Now it's just my sketch. So I'm going to bring back that pocket. So there you can see it's standing out. It's 12. Now we want to cut it forward. Now, yes, mid-plane would have worked, obviously, if I've positioned my part when I extruded it. If I extruded it both ways, then yeah, your sort of plane would be in the middle, but still that little whole thing, yeah, that could have worked. And then you can cut them both ways again. So that's definitely a way to go about doing it. And that is, again, something that you need to consider before starting the part, because I started off with the sketch being right on the plane, and I just extruded it one way. And so now the plane is at the back of the part, versus if I've extruded it both sides equally, then the plane would have been in the middle, and then my approach to this would have been completely different. But now it's at the back, so now I have to do another approach. And again, that is, again, personal preference, so everybody's approach will be different. In the end, it works, gets the job done, so that's fine. So let's see, this needs to be 24. So it's currently on this side here. So we're just going to cut 24 to the front. So I'm going to select the sketch over there and I'm going to say cut. And it's going to be 24. And now if we look, we can see it's going the wrong way. So we just say reverse. And yeah, that seems to be correct. So let's just do it there. And that's everything. So that seems to be everything they ask. It looks the same. It's the nice blue color. Everything we've cut in there, we've cut there, we've cut here in the middle, added the extra hole. So everything looks to be correct. So now the time has come to measure it again, to just go and see what the weight is or the mass. So again, macro, recent macro, center of mass. Oops, forgot to select an object. So body, again, you always need to select it before you activate the macro. And it's becoming a bit repetitive, but we have to go and change the density. Yeah, it's like every CAD engineer's dream, isn't it? When you get that sketch fully defined, oh, it's just like, it's really nice. So let's see if that is the correct answer. I keep on 628.18. Done. It's exactly the same. Hurrah! So that's worked out perfectly. So we did our sketch correctly. Everything is fine. Everything's worked out. Let's go to the next one. Now the next one is this one is really horrible to replicate in FreeCAD, because like I said, in Solidworks it's so easy. You just do offset entities with 1 millimeter and it creates the nice outline. You cut it, you repeat it, you cut it, and you're done. So offset entities is not a thing in FreeCAD. It's not there. So you have to go and manually trace the whole thing again, offset it by 1 millimeter yourself, which takes time. But it's fine. It's absolutely fine. I don't mind doing it. it's just not, it's just a little bit sort of, yeah, there's a faster way of doing it and I can't use it because, yeah. All right, so there was the plane at the front that we've created. So we're gonna do a sketch on it again. So I've just made it visible so that I can see it's the correct one. Let's just change it. All right, so we need to go and cut a part out here. Now, like I mentioned, I can't do offset entities by 1 millimeter, so I am going to do it another way, which takes a bit longer, but it still gets the job done. So again, my go-to little tool is my little, oops, did that work? That work? Yes, there we go. And that one. And here at the bottom, that part there, that part there, that part there. Okay, so that was everything. And now we need to go and add that other cut that was over there. It might work. Let's try this. I haven't done this in the previous one. We can just select that edge over there. Go back. Oh yeah, it's there. Great stuff. That's nice. I didn't do that in my preparation. So, okay, so there we've got everything. So I'm going to hide my pocket again. Hide pocket. Go away. Let's just do that. Okay, so there is my sketch. I wonder if I can, yeah, let's just go front. Okay, so there's the sketch, the outline. That is sort of the outline, but now we need to go and change it. That's 1 millimeter offset. Okay, so one way to go about doing it is first we, sorry, just gonna. Okay, so I'm gonna. Ooh, sorry. That's something in my throat. Ooh. Okay, so I'm gonna trace over the purple again, just so that I can have a sketch. We're gonna start off there at the bottom or the top. Go over there. Go over there. That part there. Just forgot that little line over there. Choop, choop. Okay, now we have our circles. Click on the midpoint first. Over there. Over there. There we go. Click on the midpoint. Nope, missed it. Midpoint over there. Oh, the little dot. Okay, so now we've gone and we've traced it, fully defined, and now we need to go and offset it. So one way to go about doing this, don't know if it's the best way, but it's a way, is to go and copy this whole thing. So I think we can select it all. Oops. What happened now? Did I go out? Oh, there we go. Wait, wait, wait. Am I in the sketch? Yes. There's pocket. Oops, pocket. Just go away. Go away, pocket. There we go. Okay, so one way to go about doing it is to copy it. And there's a function in Sketcher that allows you to copy it. So when I go and I'm just going to select everything, because it seems like when I do the bounding box, it doesn't work. And then you can see here's a copy feature here. So create a clone or a copy. So I'm going to create a copy from a single sketch. Okay, just do sketch. Oops, what did I just do now? Did I clone it? Oh, I think I've cloned it. Let's just do it again. Sketch, and I want to copy it. Select elements from a single sketch. Yes, that is what I am doing. Okay, I've selected it. Let's try again. Okay, so I'm going to copy it. Boop. All right, there's it. Now, what you can do now is we can go and we can do it manually and just decrease the size of it and then have little construction lines that says, oh, this needs to be a millimeter, 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 and then have it all the same size, and then dimension that to be 1 millimeter, and then that would sort of put it in. So that's essentially what we're going to do. I was just thinking now, I've done it all I skipped that part. All right, yeah, so I've skipped that part. So usually I would just go and cut this front part here and then cut in there. I've just gone and done this whole part here. So I'm just going to cut through there and then I'll do that a little bit there. Again, same result, just different approach. So what I can do, what I'm going to do now, I'm just going to drag the points to inside the part. And yeah, I know it's cringeworthy in a sense because there's so much better way to do it, but for this exercise, it gets the job done. And I'm just going to bring that one in. Okay, that was supposed to be there. And that one was supposed to be there. Come back, you. Come back. And bring that one over there. Oh no, this is going to take forever. All right, so, oh, that one, come back here. It's that one. Okay, so it's sort of inside the one that we want to do. So now we can go and dimension it. So I know that the outer circle was the radius of 41. So now because I want it 1 millimeter in, it now needs to be a radius of 42. So let's just confirm that again before I go on and make it and it's not correct. Yeah, 41, so it needs to be 42 now. So then that circle will be 1 millimeter inwards, meaning we'll get a wall thickness of 1. So that's the first thing that we're going to do. We're going to put this one and we're going to say radius of 42. And then what we can do, we can align these two. No man, what's going on? Why is it turning black? Let's just go task, just close it again. Try it again. Hide our pocket again. Seems like it doesn't like it when I do the little box thing. So I just select those two. Select them and then make them equal. I did. I select two of them. Come on. There we go. Okay, so now you can see that two sort of half circles or circle edges, they are 1 millimeter apart. So that wall thickness is correct. So that's what we want. Now for the rest, oh well, there's another circle here, which is the same. I think that one was 19, radius of 19. Let's just go back and have a look. Yeah, it was a radius of 19. So now we're going to make it a radius of 20. So then that, again, we get a nice hole thickness, a wall thickness of 1 millimeter. So we do that. And we say, what was it, 19, so it's 20 now. We say, okay. A radius of 20, yeah, why does it look so bad? Okay, and now we select two center points and we join them. All right, so now we've got those two lines. So that wall thickness is correct. Now the only thing left to do now is to create our little construction lines for the straight parts, and we can also just go and say for these ones that are actually straight and vertical, just give them relationships. Okay, so that's fine. And now, so we can go here and we can do our construction lines. So we link them. So when they're blue, they mean they're construction lines. So we just go one over there, one over there, one over there. Oops, that one didn't touch. It's okay. Let's try that again. Touch it, and then the last one is this one over here. No, I didn't touch it. Okay, and now, in order to make sure that this is in fact 1 millimeter, we need to create little relationships between two, and so they are perpendicular. This one and this one is also perpendicular. So now they are perpendicular, so you know that distance will be 1 millimeter. That one is already perpendicular, so these two are fine. Is that one straight? That one doesn't look straight. Let's just make that one straight. Zoom a bit in. Vertical. All right, that's fine. And then it's only this one at the top that we need to make sure is perpendicular with the lines it touches. And that one over there, perpendicular. All right, so now our construction lines are correct. And you can see it looks, we're almost there. So now we just need to make sure they are all 1 millimeter. So I'm going to go and I'm going to select all of them. So I hold in the control key. I'm just going to select all of them. And I'm going to say they are equal. So they are equal. And then I only need to dimension one of them and the rest will follow suit. So I'm just going to say this one is 1 millimeter. All right, so that is 1 millimeter. Now the rest will all be 1 millimeter. So that's great. I have gone and done it. So let's just go out of the sketch. Oh, I forgot to do one thing. So currently the ones that oh man, let's just pocket go away. So the outside ones are obviously just sketch because I've traced over them. So I need to make them construction lines as well, or else they will be used in my cut. And I don't want them to be used. Oh, come on. So I just need to turn them into construction lines. So I just basically select all of them. The outside ones. Ah! This is not fun. So let's just change them over before I do that mistake again. So you can see they turn blue, meaning they're construction lines now, so they're not going to be used in my cut. All right, so now just the inside part, my little offset is going to be used. So we're going to say close. Okay, so only that, so you can see only that. And now we can actually go and bring that back. And now we can cut into the part. Okay, and now it's going in. Now, if we look at how much it should be, it's all the way just to 12. So we know the distance, the full extrusion length is dimension C in my spreadsheet. So we can just say dimension C subtract 12 and it will give me that distance. So we're going to go here at the side. We're going to say spreadsheet dim C, dimension C minus 12. And there we go. Let's go look. Yeah, that looks good. So it's gone now and cut deep into it. We can also look, it's not, the wall is still there, so it hasn't gone through that little cut that we did here, so that's fine. The wall seems to be 1 millimeter, so fingers crossed we'll have a look at the dimensions, but it looks good. So like I said, I've gone and did this part first, so now I need to just do this little cut over here. So that would be the last part of this part, so I'm just going to save that again. We're going to use our original plane. I'm just going to, yeah, that's the correct plane. Going to create another sketch. Now, if we look, so that needs to now do that whole thing over there. So same sort of exercise again, just copying the edges. So that edge we need, that edge we need, that edge we need, that edge we need, and that edge we need. And then we can actually take this edge as well. It shouldn't matter, but I'm not going to do it. I'll draw it separately. We actually don't, yeah, it's, yeah. We can actually do this whole thing. We can actually use this here because it's been already offset by 1 millimeter. So I'm not going to do that. That's a part there, and I'm not going to do that. So we're going to use that as well. So because it's already been offset, I'm just going to reuse it again. All right, so that's all been created. I'm just going to hide it again just to make my life a little bit easier. See what's going on. So there's my already offset part. I'm going to retrace. Actually, maybe I don't need to because I can just do the offset as is and save a bit of time. So I'm just going to do that. Let's see if that works. So I'm going to go that point, somewhere there, somewhere there, somewhere there. Because it's not that complex of a geometry. I can just go and trace it myself rather than using the copying feature that I showed you of the other one. All right, so I've done that, and now I just need to do that. So I said this was 19, so it needs to be 20 again. So we're going to use our little partial circle. I'm going to go there because I can just, it should be, there we go. All right, so got everything. And now only thing I need to do is maybe add some dimensions. So that one is straight. Okay, and that one's already straight. This one needs to be straight. Okay, it's already straight. All right, so now I just add my little construction lines. Let's just go back to construction. So between that one, that one, that one, that one. And I think, okay, so this one just needs to go there. And I know these other two has already been offset, so I don't need to worry about them. And that half circle over there has already been offset, so I don't need to worry about that one either. Or it will just update as well. So that one is it straight? Yeah, that's straight. So I just need to go and create a variable perpendicular to that and that one needs to be perpendicular as well. All right, so it updates that. And let's just move that line a bit. And then this one also just needs to be given that constraints. Okay, so we got that. Okay, so everything's fine. Now I just need to tell them that all four of these are equal in length. Boop. Okay, equal in length, and now just one of them need to be dimensioned. This one. 1 millimeter already. Okay, yeah, so that's already been 1 millimeter, so I don't need to worry about that. All right, so there's that part. So that was fairly straightforward. So I can exit my sketch. And there's that part. So looking at that, that needs to be cut only 1 millimeter to the back. So to do that, we're going to take our C, -12, -24, -1 to get the depth of the cut we want. So we're going to go and say sketch. Let's make our pocket visible again. Sketch cut. And this time, so we're going to say, let's just do it that way. So spreadsheet, spreadsheet, dimension C. So that is -12, -24. So -12, -24, -1 to get our wall depth or wall thickness 1 millimeter. That gives us 7. We can say okay. Come on. And that looks correct. Right, so we got our part over there. That looks nice. Yeah, let's save that. And that is everything. So that is essentially the last configuration of this part. The only thing left to do now is to get its mass. So gonna select the whole thing, gonna go to macro, recent macros, center of mass, and we're going to give it its density, which is 7.9. I'm gonna say yes please, and it's 432. Let's go have a look and see if that is in fact our value. 432.58. This one is 430.61. Now that discrepancy is as a result of my very rough offset entities for that wall thickness. So I guess that difference came as a result of that. Obviously, if it was in SolidWorks, you just had that very nice convert entities or offset entities, and you specify 1 millimeter, and it would have done that. But this is within 1% errors, so that still goes. So yeah, I'm happy with that. So that is the part modeling and the mass and everything. So yeah, most toughest one to complete, and it seems to be done fairly easily. So looking at that, I can basically say that all of this, FreeCAD can basically do all of this that SolidWorks can do. Obviously, there's some tools lacking from FreeCAD that SolidWorks has, but that makes absolutely sense. SolidWorks being a paid product, a lot more money to add all these additional features and little ease of use. But FreeCAD, you can still get around that, as I've just shown you with my little how to do wall thickness of 1 millimeter. So that's pod modeling. Let's move on to the assembly. Now the assembly is quite different. The assembly, I must say, is really different. It's really different. In a sense, I like it. I like it in a sense, but also not. We'll see. So we're going to assembly for workbench. I'm just going to bring that up. Seems like it's activated. Okay, it's activated it. Has it? No, it hasn't. Come on, assembly 4. It's activating it. Has it done it? Oh, let's just say new part because I've closed it. All right, so how this works, and if you go onto YouTube and if you go to a lot of other tutorials, there's a bunch of different ways to approach this. Now I'm going to do one approach. Obviously, there are others that you can do. This one just worked for me. So the approach I'm going to do is I'm going to create separate files or separate assemblies for each part that I'm going to use. Now, if we go to the question, let's just go back to the question. This is essentially what we're going to use, and we're going to use 3 parts. So we've got our long rod, which is in green, a sort of a yellow connector, and a smaller pin, which is in blue. So it's 3 parts, and then so I'm gonna create 4 files. So the master assembly file, and then 3 different assembly files, which will contain each part in it. No, so there'll be 4 different files. Other ways of doing it, which I haven't tested out, is you just create 1 file, and then there's a separate part for the created in this assembly file where you input your different parts and then you just link to them, which is again another way of doing it. I'm just going to do it this way. So I've just created a new file, and then we go here at the top, which says create a new assembly container. And if I click that, you can see here already on the tree, there's the parts folder and there's the assembly. So then you can put your parts in the part folder and you can just link to it through your assembly. But I'm just going to create 4 separate ones. So I'm just going to save that, and I'm going to do, let me just see, I'm in the correct folder. So I'm just going to say this is the master assembly folder, master assembly, and then I'm going to create a new file, and I'm going to create a new assembly container, and this is going to be my, I think this is the short pin one. Let's just do the short pin. So this is short pin. I'm going to save that and create a new file, new container, and I'm going to save it again, and I'm going to say this is the long pin. Okay, I'm going to save that, and then the last one, new file, and I'm going to create it. I'm going to save it. I think this one is called the chain link. So chain link. All right, so now I've got 4 separate files. One is the master assembly. We're going to put everything, and the others are my separate parts. And it's also what they're saying, you need to now close everything and open them all up again so that the path is correctly set, in a sense. So I'm just going to do that. Let's just go back to where I've gone and saved them, and it seems like I've did. Okay, so there they are. Long pin. Where's my short pin? Oops, nope. Master assembly, long pin, short pin, and chain link. There we go. Open it up. All right, so they're all 4 of them now completed. All right, and now I'm going to, so what I've done is I opened up Solidworks, I imported the parts there, I converted them to step files, which now I'm going to import into FreeCAD, so then I don't need to build the whole thing from scratch. So we're going to start at the short pin. I'm just going to say import. I'm going to go back there, and my step file should be there, and it's not there. Let's go back. Oops, wrong one, back. It's not there. Supported formats. Why is it not there? Okay, so I need to go grab it from my external. Let's go grab them from my external. All right, so I've got my, which one was this? This was the short pin step file. Input in there, there's my short pin, and you can see it's the short pin. I can put that, I think, in the assembly, and now it's there with all its local coordinate systems and stuff. So there's the local coordinate system there at the top. If we look at, so when you approach this, you need to always make sure that your master coordinate system is correct. And you can see here it's at the top of the long pin. The short pin, in a sense, it can be on the side, but now, and this is the thing with assembly 4, you need to add local coordinate systems, because you're going to essentially, when SolidWorks, you use the mate feature to mate faces and points and lines together and circles, make them concentric and such. With the assembly 4 workbench, you need to mate local coordinate systems together. So we can see here, we have our local coordinate system here on the side of the pin. And thinking about it, I'm going to need another one which is in the middle of the pin as well. So you can actually go and select the part, and then here is an option to add a local coordinate system. There we are. So new coordinate system, let's just do that, assembly, new coordinate system. And now you can call it whatever, and then obviously if you add a lot of local coordinate systems, it'd be good practice to sort of rename them, because local coordinate system 1, 2, 3, 4, 5 is not really descriptive. So I'm just going to call it short pin. Oh, I didn't spell that correct. Short pin center local coordinate system. All right, so now it's gone, and now I need to select. I'm just going to select the part, and then inertial there. So it's there. You can see it's sticking out there. It's, no. It's selecting. Let's just do the short pin. Yeah, that looks to be right. Okay. Okay, short. Yeah, it's not the face. It's not the face. Let's just do that. Let's try again. Okay, this is not right. Let's try again. Concentric. Okay, so now it's on the side here. So we want it in the center, so that's what it is. So we can go and we can actually offset it into the direction, and this is the Y direction. So let's just see. Oh, no, it's not the Y direction. Is it the Z direction? Yeah, it's the Z direction. Because I actually don't know what this length of this thing is. Let's just try something else. Let's just delete that. Okay, so there we go. Let's try another new coordinate system. Assembly. New coordinate system. So short pin center local coordinate system. And I wonder if I just can, no, I can't. Okay. Face inertial. Okay. All right, so I'm gonna have to move it to the middle. Some unknown reason it's being difficult to get it. Doesn't want me to. So let's just see. Let's just measure it. Let's leave it here for now. I'll go edit it right afterwards. Just recompute that, and then just let's measure quickly the sides just to see how long it is. So I can put it in the middle. 100, so about 50. So I think we can do it about 50. So it needs to be 15. So we can go. We can edit this, edit the datum line, and now we can move it 50 in. So I think that was the X, right? Doesn't move. Okay, let's just do that 50, and it has just rotated. Okay, so that was not the right one. Wasn't. It's always difficult. Oh, it was rotating. I wasn't doing it. It's the wrong one. Let's just try it again. So I was rotating it by degrees. I should be in the Z direction. It should be 50. Okay, so now it's in the middle. So now I've got one on the side, I've one in the middle. So that's great. I don't need any other local coordinate systems for the short pin. So I'm happy with that. I'm just going to save it, and I'm going to move on to the others. So I've got the short pin. So let's move on to the long pin. Again, we are going to go and import it. So there's my long pin step file that I've gone and created from SolidWorks. And now this one is quite important, because if you look at our question, the long pin, the master coordinate system's there at the top. So you want a coordinate system to be at the top of the pin. So already when you import it, you can see there it is at the top. There it is at the top. And we don't really need anything else, because we only need that coordinate system. So if we import it into the master assembly, it will be linking that coordinate system with the master one. So our pin will be in the correct place. And then the only other place where we're going to use this right at the end of the chain, and it's going to be at the top. So then again, we just need the coordinate system at the top. So we can just leave it as is. We don't need to add any other local coordinate systems. So we're fine with that. I'm just going to bring that into the assembly, and I'm then going to save it. All right, so the long pin is fine. And then the only thing left is our chain link. So again, I'm going to import my little step file, which I've gotten from SolidWorks, chain link. All right, so now this one, we need to add more local coordinate systems, because you can see there's a little red line sticking out. It's in the center of the part. We're not going to use it at all in the center. we want ones that's here at the edge, as well at the edge over there, because so we're gonna, you can see there's the edge there, so we want a local coordinate system to be at the edge on the one hole, and then we want local coordinate systems to be here in the side here as well. Also, because with the short pin, we've added a local coordinate system right in the middle, and you can see here it connects with the short pin. So we might actually want to put another local coordinate system in the middle of the one hole on the one side, so then those two can mate correctly as well. So those things you need to think about when using the assembly for workbenches. Where do I need those local coordinate systems to, when I do and actually put everything together, I can then use them to quickly go and mate all the parts together. Okay, so first thing is we need to go and get this one at the side and then one in the middle. So just going to put that one in the assembly, and then we're going to say, all right, local coordinate system. So let's say, what are we going to name this one? We're going to say single, because it's a single protrusion, where the other one is two protrusions. Let's just say single edge. Let's do the edge one first, local coordinate system. Okay, single edge local coordinate system, and we're just going to do it over there, and we're going to say concentric. So now if you look at it, yeah, it is in the middle of the circle, and it's on the side. Did I say this is the side one? I did say edge. Yes, I did say edge. Yes. So this is the edge local coordinate system for the single one. I can't even remember what I renamed it, but that's fine. So that's fine. So we're happy with that. Single edge. Okay, yeah. So that's fine. But now we want one in the center as well. So we can just go and say we can create another one. Let's just save it, recompute it, select the assembly. I don't know if we need to. Okay. And now, so now we have, what do we call it? Single edge. Single edge middle. So this is in the middle local coordinate system. Okay, so this one is now in the middle. So we're going to select again. Maybe let's do that one, inertial, and it seems to be in the middle. Yeah. No, that one is to the side. Okay, so that's not going to work. That one is not going to work. So we need something else. Let's do that. Let's try again the edge. Oops. And then we're going to say concentric again, but now it's in right exactly where we want it, and now we need to move it a bit into the middle. So I think this one is 20 if I can remember correctly, and we need to translate it in the X direction. So let's just see if that's going to work. Boop, boop. No, it's not going to work. Y direction? Nope. Z direction. Yeah, other side. 10 seems to be in the middle. Let's just measure it quickly. I'm just going to say okay here, just so that it's there. Let's just save it. Let's just measure this thing quickly. What is it? 8. Okay. Do points. Let's do line over there, line over there. No, man. These measurement stuff, you do miss the measure tool of Solidworks. Let's see if we can get a point there, point over there. Okay, that is about 40. All right, so the middle was 20, so I got that one wrong. Okay, so we need to change the middle one. We edit that and we offset it not by 10, but by 20. Okay, cool, that's done. All right, so now we've got one on the side, we've got one in the middle, and then now for the double side, we only need one at the side, at the edge or the perimeter of the circle. So again, we're going to go and say new coordinate system. So we're going to call it, the other one was double, single, we're going to call this double. What do we call it? Double edge. Okay. Okay, so it's double edge. Let's try that again. Want to try and stay consistent with my naming. Double edge side local coordinate system. Okay, and we're just going to click this side over there. We're going to say concentric, and it's put it over there. One thing you can notice, and if you really want to be very neat about it, you can your local coordinate systems to all align correctly. So you can see you can see the blue is usually the z-axis. So with this one, my z-axis is going up. With this one, my z-axis is going to this side and it's going to that side. So it's everywhere, and that will make your life easier if you align them all correctly. For now, I'm just not gonna bother, but it is helpful if you've got a very complex part or you just want to streamline your time. So let's just recompute that. All right, so now we've got everything. So now we've got all the local coordinate systems that we want. We've got all the parts in their own little folder. So now we can go and head on over to the master assembly. And there you can see there's the master coordinate system. Y, X, and Z, and Z. So blue is our X1. So we need to make sure that it actually goes something like that. So I'm just trying to bring it a bit up so it is similar. So we want the Y to be at top. So Y is top, Z is to the right, X is to the right, which is red, and Z is literally somewhere out of the page. So now it's orientated correctly. So we just need to make sure that our long pin is right. So now we're going to go and we're going to input our first part. So we're going to click over here, and you can see they all are. So we're going to do long pin first, and because there are two long pins, I'm just going to say this is long pin number 1. I'm going to say insert it, and it's actually gone and inserted it correctly. So looking at that, we can see, maybe let's orientate it a bit better. Okay. So we can see we've got our y-axis going up, our x-axis going to the side, and our z-axis going out. And when we look at that, that is correctly, that is how we want it. And this is really important to make sure that our center of mass coordinates are correct, because the coordinates for the center of mass is given in the x, y, and z direction. So if that coordinate system is not correct as per the drawing, then the output will not be the same. All right, so we got that, so we're happy with that. Don't need to change anything. So we need to just say long pin needs to be with origin. It needs to be the parent assembly origin. So this is where you do your mating. In a sense, you're mating all the local coordinate systems to where you are. And this is where you can see it becomes important to add additional local coordinate systems, because you're going to use that to add the parts together, or to mate them together, as would be the jargon in SolidWorks. All right, so that one is over there. So next up is our chain link. So again, we're starting. So chain link, so there's a bunch of chain links. So we're just going to say this is the first chain link in the links. And now it's already put it in there. It's automatically defaulted to the sort of center local coordinate system, which is not what we want. We want the single edge, just the single edge one. And we're going to attach it to our long pin, its origin. So there you can see it's over there. And now here you can see, because my local coordinate system's got different x and y directions and everywhere, this is sort of the way it sort of goes. If it aligns the local coordinates with the x-axis with the x-axis and the y-axis with the y-axis, this is how it will look. But then obviously I didn't bother to align them correctly or keep everything consistent, so it's not correct. So, but now here at the bottom, you can go and you can rotate it. So I think it's like that, yeah. There we go. So we just rotate that and we say, okay. So there's our first two parts. So that's done. Next is our short pin. So the short pin is the next one. So again, we input it, short pin, because the part is already open in one of our files, which is going to say short pin. And now we want to do the edges. So we want to make the edges. So we're going to say attach to the chain link 1. And we want to go from our short pin center. That's not the one. We want the origin, which was at the edge. And we want the single edge one. So it's going to be over there. And it doesn't seem like it wants to do that. Single edge middle. Oh, let's do that. Let's do the centers together. Oh no, double edge. There we go. There we go. And again, so the local coordinate systems are correct, but the part is still not right, but we can go and we can rotate it. So I think this one is X. There we go. Yeah. Okay. Oh, it's getting on. It's getting on. So we've got our long pin, we've got our chain link, and our first short pin. So now we need to go and add our second chain link, and this is now where it becomes critical that we had the center point, because now as we want to rotate it, we need to make sure that we are, so what I did is with all the previous parts, I rotated them until they are correct. Now that rotation we can change, and that is where we're going to use this A value. So I've just done it with 90 degrees intervals, but then after you pressed OK, you can go back and you can change it to whatever value, and this is where we're going to input the A value. So we're going to just do that, and we're going to input another chain link. So we're going to say there, chain link, and this is now our second chain link, so we're going to rename that to second chain link, and we want to select that and we want to put it onto the short pin. Now the chain link, we've got our single middle part that we want, and we want the short pin center as well. So now you can see it's correctly, but it's in the incorrect sort of position, so we need to go and we need to rotate it forward. So to do that, I think this is across the Z-axis. Yeah. So now it's gone in 90% intervals, 90 degrees intervals, but now it's straight with the other one, which is fine for now. It's not what we want, but when we insert it, we just say okay. And now we can go back. So if we go chain link number 2, and if we go to the side, we can see here's an assembly option, and you can see, where's it, attachment. So attachment, you click here, little 3 dots there on the side, and it opens up the translation and rotation, and you can see here angle 180 degrees. So it's 180 degrees. Obviously we want it to be slanted a bit down, and A here is 25 degrees. So now we just need to have a look and see. Let's see if we decrease it. Oh, it doesn't do anything. Okay, let's just do 180 plus 25. Okay, so it does go down. So that's what we want. So we wanted, so 180 was the horizontal. We added 25 degrees, so it went down a bit. So that's where we want it. And that is correct. So now it is positioned as per the requirements over here. 25 degrees for A is there. Yeah, it's getting there. It's getting there. So next up again, short pin. So short pin, this is the second short pin. Second short pin, insert. All right, so we're going to attach it to our second chain link, and we're just going to do the edges. So origin for our short pin and single edge. Oh no, double edge side. There we go. And again, so correctly orientated, we just need to rotate it again so that it's in position. Seems like this one is x-axis. Is that correct? Yeah, x-axis. Okay. All right, so there's that one. Now we continue building the chain. So again, another chain link. This is the third chain link. So we're just going to say, all right, put a little 3 next to it, and it's going to be connected to the second short pin. Where's short pin 2? All right, so now we need to go for the short pin, or for our chain link. It is the single edge middle and short pin middle. And again, now it's correctly orientated. We just need to rotate it again. And for inserting it, it seems like this one is on the Z-axis. Yeah, so we rotate it. Obviously the angle is not correct as yet, but now we can go back and we can go change that. So short link 3, we go in here in the properties, we go to assembly, attachment, we just press that little 3 thing. So it's 180 degrees now, and if we go back, it needs to be B. So B is, so I need to get a value for that. So B was given here as 125. Let's just see what happens if we put 125 in there. Okay, so it orientates correctly. That is correct angle. So we're happy with that. So now that chain link is correct. And now we need to add the short link again. It's all very repetitive, but we're getting there. We're getting there. So this is the third short link. Yeah, third short link. So we just add a little 3 on the side, and it's going to be connected to our chain link 3. Again, for this one, we're just going to do the origin for the short link and the single edge. Oops, where's it gone? Where's it gone? Huh, let's retry that. I think I've mated it incorrectly. Let's just try again. Was it added now here? Short pin 3. Oh, there's it. Let's just do assembly, edit placement. So chain link 3, that's correct. Short pin edge, single edge. Why is it not there? I don't see it. I don't see it. Why is it not there? Okay, maybe let's just delete it and redo it. Oops, oops, I've done something there. Okay, so let's just redo it. So we're going to Short pin, that's number 3. It's going to be chain link 3, that one, that's correct. So short pin is the origin. Okay, so there's it at the moment. And we want chain link 3. Chain link 3, I wonder if it's not seeing chain link. That's not, okay. Single edge, double edge side. Okay, there we go. So now it's there where it's supposed to be. And we need to rotate it again around Z. Yeah, there we go. It's in position. Okay, so we got 3 chain links. I think we just need 1 more. Yeah, 1 more before we do the long pin again. We're going to go import chain link. I think this is the 4th chain link. Insert. So again, now we're going to go and do it on the short pin. And we're going to do it on the single edge middle, short pin middle. Okay, all right. Now we need to rotate it, and it seems this one is blue, which is the, there we go. Ah, that's nice. Ah, it looks good, it looks good. Now we just need to go and select it and update that angle. So looking here, it's C, angle C, and angle E was 130 degrees. So we go to, we're at assembly, we just say 130. Oh, so that one is not right, it's the wrong direction. So now we need to change that where we are now. So that is 180 minus 130. Oh, not wrong. Okay, wait. My maths is a bit wrong at the moment. So it's 50, so it's 180 plus 50. There we go. There we go. 3rd time lucky. So now that's correctly positioned. So we got all our links, and now the only thing left is our long pin, the end of everything. Yeah, I'm just going to save everything for now because don't want to lose it now while I'm at the end. So last part is our long pin, and because this is the 2nd long pin, just going to insert that. So we're going to attach it to our chain link, and we're going to do the origin of our pin, and we're going to do the double edge side, and there it goes. Oh, but it's not correctly orientated, so we just need to go and rotate it. It seems like it's the green one, which is Y. Nope, it's not the Y, it's the Z. Nope, it's not the Z. Let's just get it back. So it's X. There we go. All right, and there we go. That is it done. So it's all imported, or all in. Links, angles are correct as per our requirements for the test. The only thing left now is to get our center of mass. Now here's a funny thing again. Being FreeCAD, if we use the macro looks at a part. And I've tried this, and I can show you again. If I select, so you always need to select the part first, or the thing that you want, the mass or the center of gravity or center of mass. You need to select it first, and then you go to the macro, you select it, center of mass. And then here at the bottom, there's some error going up. Something's wrong. And I thought, well, I'm not going to struggle with the error. I know it works for a single part, which I've just shown in my creation of the little part. So what I can do is, and I'm going to do this, and I'm going to say, all right, master assembly. I'm going to go, and I'm going to export it as a step file. I'm just going to go and I'm going to export it master assembly, because this is the first question. I'm just going to say master assembly 1. I'm going to save it, and so now it's a step file, and we're going to create a part file, and I'm going to import it again. It's I'm going to import it, and there it is again. This one over there. So no, it's supposed to look like that. Yeah. Oh no. All right. Anyway, so now it's a part. Now it's not an assembly. It's just a part. It's been imported by a step part, and now I can just select it, and now it works. And now I can do center of mass, and it gives it to me. But obviously, I need to update the density. And this was titanium, which is 4,600 kilograms per cubic meter. It does give me a mass of 33 kilograms, and it gives me the center of mass, and this is X, Y, Z coordinates in meters. Now if we go to our answer, first one is 348.66, so that is about right. It's out with a, what's it, hundredth of a millimeter. Y is a bit, so that's 88, this is 95, so it's out with 7 millimeters, and then the Z one is out with 1 millimeter. So got that almost right. Managed to see if there was an error that I made. It does not seem like there's an error. It might be just the macro or something from my side that I've done wrong, but I did not manage to get it closer to this. It's always the Y coordinates, the Y coordinate that is offset the most, so this, in this case 7 millimeters, where the others are either almost exactly the same or varying by 1 millimeter. And when we look at our part, we can see that there is not really anything wrong with it, so it is actually correct. Everything is correct, correctly aligned, everything is fine. So that might be something in terms of the calculation of the center of mass. It might be interesting to go later and have a look at the other macro that I mentioned at the start, the FC info one, which also does the center of mass. Might be good to go have a look at that, maybe see if it gives the right answer, the same answer as the other macro that I'm using currently. But it seems like that is as close as I'm going to get. So I'll take that as an answer. It does seem to work. Assembly for Workbench does get the job done in terms of doing this assembly. The thing that you just need to do, and that's the thing that's different from SolidWorks, for instance, is that you need to put some forethought into where your local coordinate systems need to be. And where you need to put them to make your life easier, because obviously you can just keep them all to the edge or to the local coordinate system that's given, the only one that's given when the part's created, but then it does make your life a bit more difficult because then you need to rotate it, you need to sort of move it, translate it. So having additional coordinate systems put into the part before you assemble the whole thing will make your life easier, as I've just shown you with the ones I've added. So just to show you, obviously I've added 25, 125 and 130 degrees in my rotations. The thing now is just, the only thing that's left in this question is now to update that. So we can quickly do that. And obviously I haven't gone, again, you can use the spreadsheet for this. So you can just say, all right, ABC, dimension, ABC degrees. You can do the spreadsheet and you can just update that. I haven't done that this time, so I need to go now manually and change that. So obviously the dimension, the first one is here, which was 30 degrees. And now we can go and let's just go into our master assembly, chain link number 2. We go down and we just say from the assembly, there's an attachment. And that was 205. So now that's 30 degrees. So let's just go. So 180 plus 30. And it just goes a bit down, so that's fine. And the second one, where's that chain link? Oh, let's just save that as, or maybe let's just, yeah, that's fine. So that was chain link 2. So then we have chain link 3, and here it was given as 115 degrees. So if we go there and we just update that, come on. Oh, there it is. What did I say? It was 125 previously, it's now 115. So just 115. So that goes a bit more. And then the last one, let's just recompute that, is our chain link. And this time it is 135 degrees. So that was 45 in difference, yeah. So let's just go that. Attachment. So that was 180 plus 45. There we go. All right, so now it's been updated. We can save it. And now again, we do the same exercise of exporting it as a step file. Oops, I haven't selected the object I want to export, because that will just make it easier in terms of doing the measurements. So we export it. Master assembly, and this will be the second one because we've made changes. And then we just do another new file. We import it again. It's very, very rough sort of go around. Let's do that, but yeah, it does the job. All right, so again, it's not properly orientated, but in a sense that is it. And we select it and we do the macro. Center of mass. Again, we need to give it the 4,600, which is the, oh no, 4,600, which is the density. We calculate it again, and now we got different center of mass values. So now we can go and we can compare that with our value. Let's just go back here. So and again, if we compare it, 327, 325, so 2 millimeters out, minus 105, minus 98, so 2 millimeters out again, minus 101, minus 102, about a millimeter out. So it's fairly close. I had a look and try and see if there's possible errors that I might have made. I don't see any. It might be as a result of the density that's different. I had to go into they don't really give it here, so they don't give it. Well, maybe they do. So they don't give it into the questionnaire. I had to go and grab it from SolidWorks, so that might be an error somewhere there. Might be some decimal places, but not. But this does the job. It does it. It's a bit rough sort of workaround to get the assembly working or the macro working. Again, if I had the other one, which I couldn't get added onto FreeCAD, I might have had a better go. I didn't have to export and import it as a step file. But yes, looking at FreeCAD, and if we can do the SolidWorks or the Certified SolidWorks Associate practice exam in FreeCAD, the answer is yes. Yes, you can. FreeCAD is able to do it, does it with fairly good accuracy, and I'm happy with it. Obviously, as I use it more and more and more, I'll get more acquainted to it, I'll get better at it. Practice makes perfect, and it gets the job done. So thank you very much for watching, everyone. Thanks you very much for tuning in. 2 hours, just a little bit over 2 hours. I appreciate all the comments and all the support, and I'll see you in the next video. Bye.